So this question comes from 5.1, and it says use the apparent pattern of the first few terms of the given sequence to find the formula for the nth term. And it says to assume that the sequence starts at an index of 1. That means our n is 1 to begin with. And so we've got the first 4 terms here of the sequence, and we want to look for a pattern. So the first 2 things we should do is let's see if we see an arithmetic or a geometric sequence. Do we see, am I multiplying by the same number? Am I adding the same number to get to the next number? And really, in this case, I'm not. There's nothing that I can add to get to the next, I'm sorry, not the same number, the next number of the sequence. There's nothing that I can multiply. I mean, if you take a look at the bottom of this sequence, so the bottom of the sequence, I get to the next one here, I'm multiplying by 2. To get to this one, I'm multiplying by 3. To get to this one, I'm multiplying by 4. So it's not the same number that I'm multiplied by. So that it's not really, it doesn't fit an arithmetic. It doesn't fit a geometric. So, but what I do see here is it's alternating positive and negative, positive, negative. The next one I expect to be positive. And I'm seeing that, so I would expect, like, let's predict what the next one would be. I would expect a positive square root of 2 on the top. And I saw that I multiplied by 2, multiplied by 3, multiplied by 4. Probably have to multiply by 5 to get to this next one. So I'm going to predict that the denominator here will probably be 120. So it's an alternating sequence. And alternating sequence, the one thing that to do an alternating sequence is you use this -1 to the nth power. But when I see this, -1 to the nth power, if I start, because it said to assume that the index starts at 1, if I start with an n equal to 1 here, well, I'm going to get a negative for the first term. And that's not the case here. It's positive. So what I can do is just raise it to an even power. And so how do I raise it to an even power? Well, I say n plus 1. So now that's 2, and -1 squared would be positive. But this numerator, to get the square root of 2, I have to multiply 1, positive 1, by square root of 2. So I'm done with the numerator. So that's correct. Then I need to look at this denominator and relate it to n. So the first term here is n. It's n. The second term, though, look at the second term. If this one also happens to be, this is the second term, and that is also n. So far, this would work. But it's when I get to here, this is the third term, that's not what's here. So if we take a look at, this is the fourth, this is the fifth, that pattern is actually the pattern of n factorial. And if, to refresh our minds, what n factorial means. N factorial is equal to n times n minus 1 times n minus 2, so on all the way down to n, all the way down to, what is this? It would be 3 times 2 times 1, and I think I wrote this wrong. It's multiplying all the way down, taking 1 away each time. So if you had 5 factorial, it would be 5 times 4 times 3 times 2 times 1. That's equivalent to 5 factorial. And if you multiplied all those together, 5 factorial is 120. And so this is what the denominator is here. It's the n multiplied by each number all the way down to 1, each number below it. And so this would be the answer to that question, looking for the formula for the nth